Hello. Yeah, hi. Yesterday we have completed till bus transfers, right? Have you gone through the recorded session and PPT? And also I have shared the specification. So till where you have completed and what are the doubts you have? Till
Yeah, hello. Hello,
yeah,
madam. Like I have one doubt, okay? In slide number 22, okay, there is multi-transfer.
22. Which one?
Multi-transfer. Slide number 22.
Here, huh?
Still above. Like after right read transfers, with weight states, there is a multi-transfer. Hello.
Yeah, please tell.
Actually, in slide 22, like multi-transfer, okay? Yeah, above, still above.
Okay.
This one. Actually, at cycle T3, okay? Hello?
Tell.
Like at T0, okay, this H right is right. At T1, read. And at T2, okay, H read is low, okay. That's why we are not doing read operation, right? At,
H read is low. Okay.
at T2, okay, H read is low. That's why we are not doing read.
Okay.
At T3, we are doing read operation, right? Data B.
In T3 also it is high only, right? We do the write operation.
Yeah, that means both will happen, write and read.
Mm.
Okay.
Write,
Right.
read, write.
Okay, write will happen and also read will happen, right?
Yes.
Okay. But write,
Here
read
data
the,
A,
yeah.
here data A is writing whenever write is high. Read is low here. In the next cycle it is showing because first cycle will be the address. In address phase only read should be low. So it will be reflect to the next cycle. But here P ready signal is a low. That's why it is not reading the data. That's why in next cycle it is reading the data whenever P ready is high. And
Okay.
in T3 at the same time write data. C data is writing. So here at write data we got write.
Okay.
Here B data only reading. B data is not writing.
Yeah, one more dot is H write data is there, right? Last signal.
H write. Okay.
That data here should not change till T4, right? Why it is changing at T2? That,
Okay, write is changing at T2 and here T4. T4 here it is not either 0 or 1. It is not doing both write or read. It is just constant because here we don't have any data. Here we are
yes,
not doing any operation.
yes, at like between T2 to T4, okay?
Hmm.
HW data, okay, should not change, right? It should be data A only.
Hmm. Okay.
But there is some towel is change.
Then, where do we find the toggle condition?
Like at T2, okay, HW data is changing, right? Something.
Mm.
Uh,
HW data. Okay.
It will not change, right? It will change.
Actually, Venkatesh, in one clock cycle only, this write data will happen
Okay.
to your point. So that's why from T1 to T2 only, this data is there for write A because it's just taking one clock cycle. It should happen. Am I
Okay.
right, ma'am? Right?
Here, yeah, one clock cycle or two clock cycle. Two clock cycle will be happened in term whenever it is in
Red
busy
signal.
state.
Yeah.
In busy state. Here, one clock cycle is enough to write the data. And read operation is going on, but no write. So it is waiting until write should be high. So here write is high. So immediately write data. C data is writing.
Okay.
At the same time for read, here read immediately we should get T2 only, but because of ready signal it is going to T3.
Okay. Okay. Okay.
No, observe the address phase and the data phase. You need to understand basic transfer first. It
Whatever
confusing.
we got here, whatever we did for separately, just same here also. Both write and read in one waveform. Here in address phase,
Okay.
first cycle is for setting either write or read. Next one for data. First one is address,
Right.
next second one is for data. Same thing here also happening. First cycle will be the address, second cycle will be the data. If any busy state is getting, then we
Right.
get the delays like this.
Okay. Okay. Yeah, sure. Understood.
Next. Today we will discuss on remaining concept and also we'll start with the design program,
Right. Yeah.
HB
One.
design.
Yeah.
And in the next session we will look into the UVM verification for AHB. Okay, we will have one session in the middle of this week, either Tuesday or Wednesday. Okay, one session we'll have for AHB so that we will complete the UVM AHB. Okay, yeah, tell what doubts you have.
Yeah. At page 11. Okay. Page
11.
11. Yeah. Like it's like a multi-master, multi-slave, right? ASB.
Yes.
Like at 11, okay, it is like one master, three slaves. We can
Mm.
have like three multi-master, multi-slaves also, right?
Multi-slave also. Then for
Mm.
masters, we need to use the arbitration concept.
Okay, like three masters, one slaves also we can use. Three
Ye-
masters, one slave.
Yes.
Okay. Master, then we have to use arbiter. Huh?
Mm. Yes.
Okay. Okay.
Arbitration concept we already discussed in the I2C protocol, right? Same model.
Okay. Actually, I have not attended I2C lately.
Okay.
I was attending only the Samba protocols.
I can share that recorded session. Just go through that.
Okay. Okay. Sure. Thanks.
Okay, next, so all write read transfers with wait states, multiple transfers, and master lock also explained clearly yesterday, and burst operation. So I think everyone understood about the burst, right? Where we send the multiple number of transfers at a time, not single piece of data. Okay, so in burst transfer yesterday you asked some of the examples, right? Suppose if we use the 32-bit data or 64-bit data, according to that how the size is different, right? Suppose example we are using here, there are 8-bit and 16-bit only. Suppose if it is 64-bit AHB, okay, then how many number of bits we need to convert? 64 bits. That means you can use the increment 8. Suppose example, everyone understood the burst concept in AHB? Any doubts here? What is mean by burst transfer? What is mean by burst transfer?
Transferring the data to multiple sources at a time.
Multiple
Not a
data
single bit, like 8 bit, like single bit at a time, 8 bit or 16 bit, like that.
Okay. Not 8-bit, 16-bit. In terms of words, 8-bit means in APB protocol or ITC protocol also we will transfer 8-bit, 8-bit, 8-bit only. Once 8-bit is transferred, after transferring entire 8-bit, then second transfer will be initiated and then third transfer will be initiated. But by using the burst transfer, same 8-bit or 16-bit data words, we can transfer one by one immediately. Okay, we can send many data words one after another automatically without stopping. It's a continuous data transfers. Okay, so single transfer means like CPU read only one data word. Word means how much size? 16-bit or 32-bit, whatever. Okay, double word we have, right? Like that. Burst means what? CPU reads multiple words, 16 words or 64 back to back. Okay, so suppose 64-bit. 64-bit means how can we calculate 64-bit Ahb protocol? Suppose we are using increment 8 burst. So I think you got the difference. What is the difference between increment and wrap? Right, within the range, how the increment data is address is calculating within the boundary, and in the wrap, how the data is, how the address is bounded back in the wrap. Okay, you need to understand that. Based on increment 4, wrap 4, or increment 8, wrap 8, increment 16, wrap 16, total number of bits will be differed. Okay, total number of bits will be the 16 or 8 or 4.
4.
Okay, so suppose here for 64-bit data, we are considering as a increment 8 burst transfer. Okay, then how many bits? How many bits? Suppose 8 bits if we consider. 8 bits into how much data we are transferring? 64 bits per 1 bit. Okay, 64 bits per 1 bit. That means total how many number of bits? 64 into 8.
512. 512.
512 number of bits. 512 number of bits, nothing but 64 bytes. That means 64 number of bytes we can transfer in one burst. Okay, 64 number of bytes means how many number of words? It depends on which type of word you are using, whether it's a 16-bit word or 32-bit word. Okay, in one burst, we are transferring total 64 bytes of data. In APB protocol, how did we transfer the data? Only 1 byte, 8-bit data or maximum 16-bit data. Okay, more than that we cannot able to transfer. But here we can transfer 64 byte in one burst, and that too continuously, next to 64, next to 64, next to 64. Like that we will continuously transfer number of bytes. Okay, if it is a increment 8, increment 8 means address total within the address range, the addresses will be divided into the 8. Okay, suppose if you take increment 16, increment 16 means what? Total address range will be divided into the 16. Maybe plus 2 also we can divide, or plus 4 we can divide. Okay, so 16, if you consider increment 16, then what is the value? That means 16 bits into 64 bits.
4096 bits.
64 bits per bit. Then how much? 1024 number of bits totally. 16 into 64. 1024 bits means how many number of bytes we can transfer in one burst?
128 bytes.
128
bytes.
bytes. 128 bytes of data we can transfer in a single burst. Okay, so that is what the difference between increment or burst transfers. That is how we calculate the burst size or else H size. H size is totally dependent on what value you are considering, whether increment 4 or 8 or 16 or wrap 4, 8, 16. Totally it will be dependent on these signals. Okay, so next, burst transfers are completed. So did you all understood the sequences, everyone here, the non-sequence, sequence?
Ma'am, please repeat that you explained in the print. Ma'am, please explain that you explained in the print.
See, what we are doing here means, suppose yesterday one person asked the doubt. Suppose here we are taking the burst is a 3-bit size. Okay, 3-bit size means in AHB protocol, if you transfer 8-bit data or 16-bit data, 32-bit data, how the data will be divided. Okay, in that case, what I am telling means we already seen for 32-bit data and how wrap 4, increment 4, wrap 8, increment 8. Increment 8, wrap 8 is nothing but divided into the 8 bits here. Okay, 3, 4, 3, 6, 3, 8, 3A, 3C, 3E. It's an increment. That's why even boundary reach, it keep on incrementing 4 0, next 4 2, or 4 4, 4 4 6, like that. Okay, but wrap means it don't keep on incrementing. It just once it reach the boundary, it get back to the initial value. Okay, in the same way, what I explained here means for 64 bit, if you are considering the 64 bit and wrap 8 means this total 64 bit address need to be divided into the increment 8. Okay, increment 8 burst transfer. So here we need to consider the 64-bit data that will be converted into the 8. It will be divided into the 8 burst transfer. Okay, so in that case, how much data is transferring for one burst? I am telling. Okay, so how much data it will be transferred means we need to calculate 8 bits into 64 bits per bit, 1 bit. Okay, so total 512. 8 into 64, 512 number of bytes will be transferred in one bit, one burst. Okay, what is the difference between beat and burst? Can anyone tell? Difference between beat and burst.
So burst is a group of data transfer. So basically multiple beats are transferred in one burst, but a beat is a one single transfer within a
Mm.
burst. So let's say every time one word is transferred, so we can say that's one beat is being transferred. So it will, and when these multiple beats are transferred, then we'll say one burst is transferred.
Okay, so beat is nothing but single data transfer. Okay, whenever we transfer single data in a transaction, we call it as a beat. Okay, that means one read or one write of data, like 132-bit data, 164-bit data, like that. Okay, so one beat is nothing but what here? One address phase plus one data phase. Okay, here one address phase, one data phase we call as a one beat. Okay, coming to the burst, burst is nothing but a group of multiple beats In bit, we are transferring one data only. Suppose in bit, we are transferring data A only. And in second bit, we are transferring data B. In third bit, we transfer data C. One by one, we are transferring. Burst means a group of multiple bits combined together. Okay, that means 4-bit burst. 4-bit burst means what? 4 transfers will happen one after another. That means here write A, suppose data A, data B, data C, data D is there. 4 number of beat burst, suppose. Okay, 4 beats are there. If you consider 4 beats in terms of burst, all these 4 will transfer one after another parallelly. Yesterday I told you, right? What is the difference between when you download single file and when you put the option as a multiple file download? If you download as all files in a single file download option, each file will download until completed. Okay, then only next second file will be downloaded. Once second file is completed totally, then third file will be downloaded, then fourth file will be downloaded serially. But when you put multiple download option, all 4 will be initiated at a time. All 4 PDFs, whatever the files download option will initiate at a time. But according to your internet speed or size of the file, each one will be slowly transferred. All 4 will be transferred one by one. Okay, but whatever all 4 files are there, it will initiate the transfer at a time. Okay, here also same. Burst transfer means if there are 4 burst transfers, all 4 transfer happen at one after another. That means all beats in a burst are related to one after another in a sequential manner. Okay, clear everyone? So burst is nothing but it's a set of beats transfer one after another without losing the control of the bus. Okay, so in that case, increment 4 is nothing but 4 beats we are transferring in one burst. Okay, so this total will be the one burst. In one burst, we are dividing into the 4 beats. Increment 4 means, okay, like that. Wrap 8 means wrapping address after 8. Total burst we are dividing into the 8 beats. Okay, 8 beats are transferring. Like that. Single means what? 1 beat. You can transfer directly. Single beat. Okay, so beat means one step by step. So here step by step address is incrementing. So first bit 34, next step 38, next step 37, 3C, 20, 24, 28, one by one beat. Burst means all this combination, all these beats combinedly we call as a burst. Okay, heading if you see 8 beat wrapping burst. So wrap 8, we call it as a wrap 8. Okay, clear everything? Yeah, tell. So now you will get the doubt. Now, if you see, one beat transfer means one address, one data phase transfer. One beat means. But burst means what? Multiple transfers, right? So if you observe properly here, address is T0 cycle. Okay, here after this address, here data 34 data is getting here. Okay, next in the next cycle, and 38 data of 38 T1 38 is in T1 address. First cycle is address here. Next cycle data 38 data is reading in the next cycle, read or write whatever. And 3C third cycle, that means T2. Okay, and T3 is the data for 3C. Okay, 20 in T3. So 20 next cycle data, like the 24 T4 data is in T5 next cycle. So continuously address phase plus data phase, address plus data phase, address plus data. Okay, all addresses are transferring at a time, all data also getting at a time. Okay, so how the burst, how these addresses should be aligned? As we are already know, AHB protocol is a aligned. Okay, yesterday I have shown you what is meant by unaligned. So here AHB means aligned. So we are telling that based on the burst, how the alignment should be. Okay, so the alignment should be either wrap or increment. Okay, in that we are dividing into the 8 or 4 or 16 or 64, like that number of beats we are dividing. That is what alignment means. Okay, in burst transfer we need to understand only two concepts: what is meant by increment, what is meant by burst. Okay, so increment means how many bits, 8 bit or 4 bit or 16 bit or 32 bit, like that. Okay, clear everyone?
Hello. Hello. Hi, ma'am. Hello. Am I audible?
Yes.
So I have. Can I ask one doubt?
Yeah, tell.
So now, if we have this general total, we have 32-bit address is there. Okay, and that 32-bit address we are dividing into 8. Correct. 34, 38. It's in increment manner. Correct.
Okay.
So why can we use a complete 32 single 32 address and send the whole data single burst instead of dividing into bits?
Here 32-bit data we are dividing into the 8 bits. We can divide whole 32 bits also. See, in 32-bit data, 32 we need to divide into the 8.
And my question is like, if I instead of dividing the use, if we have 8 bits in increment 8-bit per 8 into 64, that is 512 bits, correct? 512 bits.
Okay.
That all chunk of data can I send with a single address?
Yeah, we can send in single address also based on that number of bits.
Okay. Now, what is the benefit of this dividing and sending at one stretch? Is it because of some congestion, or why we are sending by dividing the data?
Because see, here whole 32 will be divided into the one transfer. Whole 32 bit means one transfer only. Okay. And after 32 bit, immediately we can initiate the second transfer, right? Like the third transfer, fourth transfer. Okay, so multiple transfers we can initiate at a time. So if you have 32 bit total means you want to send it in a 8 bits. Each bit must carry a smaller piece. Okay, so to whole 32 bit in 4 bytes. So need to split into the 8 parts. Okay, so that easy of transfer. Of course, it's in a burst. We are not transferring like APB protocol, 8 bit at a see. In APB, we transferred 8 bit first. After completing of 8 bit, then next 8 bit and then next 8 bit. But here all data we are sending in a parallelly, not serially.
How? Here also we only have one path is there. That is the data path. Correct. That is like a data will go serially only. Correct.
Here data will go serially. Okay. Yes.
I didn't understand how this parallel, because we only have that HR data path only there. Correct. The last one, either it will write or read.
Okay.
The serial means here also we are dividing the whole burst of data into 8 bits, and each bit one by one. If you see the diagram, 34 first it will send the 34, then it follow first it will be like 34, then 38, then 3C 20 something. It's one by one after another only it is sending. Correct. So how can we say it is like a parallel?
Okay. So Okay, we can send the 32-bit data directly also, but your data bus should be 32-bit wide. Whenever the data bus is 32-bit wide, we can transfer, and size will also be different. H size will be according to the 32-bit. So you can send the entire 32-bit data in one single bit. So then it will be single transfer. One bit, one complete 32-bit transfer will be happen in single transfer. Or else sometimes we divide it into the bits. Why means burst transfer is nothing but multiple bits together, right? So dividing into the bits mainly in some cases we do whenever we don't want send multiple bits one after another without rearbitration. So for faster throughput, high throughput, we use this concept, bit concept.
Okay.
Suppose if you see real-time example, suppose there is a small data, 32-bit data. You can send directly in one bit, 32-bit data. But if you have big data, 128 bytes of data, just now I have shown you the example here. If you take the 64-bit and in terms of increment 8, here we are taking 512 bits of data and here 1024 bits or bytes, whatever. Okay, so whenever we take this much size of data, obviously we need to split into the multiple bits and we need to transfer accordingly.
Okay. No, I still didn't get the concept how it is saying parallel. If you look into the data channel, it is coming in sequential manner only, right?
See here,
mean,
data is serial only. I didn't told parallel. Number of transfers will be parallel in AHB. Beats are not parallel. Beats will be serial only, one by one. Each bit happens one after another. First bit, second bit, third bit. Parallel in data means in each bit, the data lines like 32-bit, 64-bit, all transfers, all bits will done at a time in parallel.
okay. Okay. It's like the PCI lanes you mentioned earlier. Like
that. So
okay.
here 34-bit of data, 34-bit of data, 34-bit of data. In this 34-bit data, we are dividing into the number of bits. These bits will transfer serially, one by one. But this 32-bit data, comparatively with the next 32-bit data, all these lanes will do parallel communication.
Okay.
Okay.
Okay. Thanks, ma'am.
So,
Ma'am, in APB there is a single lane.
single lane in a single
APB.
lane, not here we are not talking in terms of lanes, just we are talking in terms of transfers.
Yes, ma'am, in APB there is a single transfer.
In AHB we have single transfer.
No, ma'am, in APB.
I'm not talking about APB. In APB we have single transfer only.
Yes, ma'am.
This is about the AHB, right? Hmm?
Okay, ma'am, clear.
Okay, so others, any doubts? Okay, so that is what the difference here, how the multiple data items are sending one after another, and AHB have the multiple transfers which support the multiple transfers. That's why if you observe here, the table we are telling here very clearly, increment here wrap 4, increment 4, wrap 8, increment 8, wrap 16. Increment 16 is nothing but it is burst of 4 transfers, burst of 8 transfers, burst of 16 transfers, like that. Okay, so those many transfers we are initiating here. Okay, so obviously it have multiple number of transfers.
Hello, ma'am. Hello?
Yeah.
So if I want to send a
What
single
is
burst,
the difference between transfer and transaction? What is the difference between transfer and transaction?
is it like if I want to write the data into a slave, that will be a write transaction. Write transaction. So once it is completed, if we get some acknowledgement, will say one transaction, one transfer is completed.
Okay.
That's what I.
Transaction is a process of, complete transfers. Like when transfer is sending data from master to slave, or like from one component to another component. The process of this transferring is actually one transaction.
Okay. So if you see here, suppose this one is a address phase and data phase, and third one is a data phase, and fourth one is also data phase. So total we have divided into 4 transfers. Suppose if you are considering it as a 4-bit, it's a 4 transfer. 1 bit, 1 transfer, second bit, second transfer, third bit, third transfer, fourth bit, fourth transfer. So this entire transfer is nothing but one transaction. Okay, so these transaction is divided into the multiple transfers. So this entire transfer we call it as a transaction. Okay, clear?
It's like if I have one burst is divided into 4 bits. If I completely write all 4 bits into particular memory or particular slave, then I will say complete transaction.
One transaction completed.
Okay.
Okay. So next concept.
Hello.
Yeah.
So if I have one single 32-bit address and the maximum value I will be able to write will be 32 into 16 bits. Is it like that?
32-bit into
64 bits. 16 bits.
Okay, 34 you want to divide into the 16 bits. Okay. Then plus 2 plus 2 plus 2 increment you need to do.
I'm asking a single transfer. If I want maximum address that is capable by AHB is 32 bits, correct?
Okay.
So I'm asking like what is the maximum number of bits it can send in a single address, single
In
32-bit.
protocol, we can send up to 64-bit and even 128-bit also.
Okay. And maximum bits it will.
That is more advanced protocol. In AHB, we can send maximum 64 to 128 bits.
In a single bit, correct. So H size is maximum 3 bits. So if it will be 16 bits, 16 into 128. Correct.
16 into 128. For which value?
If I have, if I am, I have like I'm choosing the increment bit size equal to 16, and I'm choosing 128 bits per bit.
See, you need to divide, like suppose you are transferring 32-bit data, 32-bit AHB system is there. So each data transfer should involve 4-byte data word, increment 4-byte, that is compulsory. If you take 64-bit, 8-byte is compulsory. Okay, so in that case, how we do the burst transfer? If you go with increment or wrap, burst length should be 1, 2, 4, 8, 16 beats. That is fixed. Maybe you will get in the starting also. Even if you see in spec, you will get that point. Maybe here didn't mention. Okay, here didn't mention, but burst length must be 1, 2, 4, 8, 16 beats only. Okay, so 32 bit, you need to divide whole 32 bit into 4 bytes. Okay, so in that case, what will be the burst length? 16. You can transfer in 16 transfers. So 16 into 4, total 64 number of bytes you can transfer in one burst. Okay, 32 bits, 32 number of bits you can transfer, total 64 number of bytes in one burst. Like that, if you consider 64 bit, okay, in 8 bytes, 8 bytes means 16 in one transfer, 16 burst length should be there. Okay, so 16 into 8, 128 bytes should be transferred in one burst. Before also I have told same example for 64-bit data.
Okay.
Okay, next.
Yeah.
Others, any doubts? Okay, so fine. Here, just here the difference, what is meant by decoder, what is meant by manager, subordinate. Manager is nothing but master, subordinate is nothing but a slave. You know what is meant by decoder already. And multiplexer, you already know what is meant by multiplexer. Based on the selection line, here 3 outputs are there. That means 3 read 1, read 2, read 3. Okay, so any one data will be sent to the master, that will be selected through the multiplexer. If you have multiple masters, we will select any one master through the arbitration concept. Okay, but here we have multiple number of slaves. Multiple number of slaves are considered, send the data to the multiplexer. Through multiplexer, we will consider any one of the slave. So this is how we interconnect AHB interfaces. AHB manager, AHB subordinate. One master, two masters, two slaves, and how AHB interconnect is there. Yeah, tell.
Like in slide 32, okay, like previous slide, this address decoding slide 32.
Okay.
Previous now this. Here this decoding, okay. This decoder we have input address 32 bit, right?
32 bit,
is
which slave it should be sent. We need to select through the decoder.
yes. Actually, that means we are
Memories
decoding 32 bit
also, if
only.
you see, if there are very big size memory, suppose 256 byte memory is there, suppose the 256 byte memory we will divide into the small memories like 32 bit data, like that. Okay, 5 32 bit data memories. How those 5 will be selected? Through the chip select. Okay, through the chip select signal, we will select any one of the memory that too connected with the decoder. In the same way here, by using the decoder, we are selecting any one of the slave.
Actually, like doubt is it is 32-bit right, input.
30 what?
The input is 32-bit.
Address is 32
The
bit, data also 32 bit.
yes. The input to the default is 32 bits. 32-bit means the output will be how many outputs will it will come some 3 or 32 outputs will come,
Read
right?
side also we have 32 bit only, right? If you see here signal list,
Yeah, 32-bit only.
32 bit.
For decoder, yeah. For decoder, okay, the
Decoder
inputs are
also.
32 bits. Yeah. The
Okay.
input is 32 bits, means the output will be for decoder output I'm saying. The decoder output will have 32 outputs, right?
Decoder output here, decoder
Yeah.
having uh, what your doubt?
Like for suppose if we have decoder input, okay, 2 bit,
Hmm.
the outputs will be 4,
Okay.
right? Like that, okay. Here the decoder input is 32 bit. And now how many outputs will be there means the 2 for 32 outputs will be there, right?
32 bit input here, 3 number of selection lines are there. So here mostly the AHB master will be initiate the address 32 bit, and here the decoder will get the range. Suppose slave 1, slave 2, slave 3 have the addresses. Okay. So suppose the slave 1 have the address between 0000. It's a 32 bit. 32 bit means in hexadecimal how much range we can write each 32 bit by 5. Suppose if you write 5 zeros to 5 Fs, each bit, each value will be 4 bits, suppose. Okay. So 5 zeros to 5 Fs. Wait, let me show.
Okay.
Slave 1, slave 2, slave 3. Slave addresses are ranging from 5 zeros to 5 Fs, maximum address range. And it's a first slave, right? So always it should be like 1. It indicate first slave. Like that, second slave might have 2 zeros to 2F. Okay. Like that, third 3 zeros to 3F. So the decoder need to check the incoming address, whatever the master is sending. Okay. So based on that, it will determine which slave range will fall under that address. Did you got my point?
And the
Yes,
first bit,
understood.
the first
Same as
bit
a
will
chip select. Same as a chip
Understood.
select. Suppose here
Yeah,
there is a decoder logic. Okay, whole 128 bit memory, 128 byte memory, we are dividing into the 5 memories. Memory 1, memory 2, memory 3, memory 4. Like that, we are dividing into the 5 memories. That means what? First memory will have first 32 bit data. Second memory will have second 32 bit to 64 bit data. Third memory will have 64 bit to 128 bit data. Next 128 to 156 or whatever. So by using the chip select, here we will, for decoder logic, we have a chip select option. Okay. So based on chip select option, if the data is should pass at 54th line, 54th line or 54th location. Okay. So where we have the 54th location? In the second memory, because its range is between 32 to 64. So the 54 bit data will be sent to this connected with this 54 line. Like that, next here in the decoder, it's selected as a 75. Okay, 75 should be at third memory. third memory location we have 75. Okay, like that it will based on the decoder logic, it will select any one of the memory. In the same way here also, based on the decoder, based on the slave address ranges, through the master, it will be select within the range. So if slave 1 is responded to the transaction, no other slaves will be selected because other address ranges do not match with the master input address, right? So whatever the master input address is matching, that slave only will be selected. So that's why here we written the ranges. You may get the doubt. Here also starting 000, here also starting FFF. Again here it is starting 00 and again it is starting FFF. That's why I have indicated 1000, 1 FFF, like the 2000, 2 FFF. Okay. Suppose if master side it is sending 1 A, B, C, D. So 1A, B, C, D means within what range? It will be checked with the slave. Okay. So 3 slaves will check which address it have. Suppose this address is there in second slave. So second slave address will be selected. To that address the data will be transferred. Okay. If this particular address is matched with the slave 1, that address will be sent to the slave 1 and parallelly the data will be sent to that slave 1 particular address. Okay.
Yeah, okay, understood.
So next to multiplexer. How the multiplexer will work? Multiplexer will be same as a normal. However, we have the selection line. Here selection line will be the decoder. See, observe. Selection line will be decoder output means what? What will be the decoder output? Nothing but this address which slave should be selected, right? Same data we are giving the selection line. Based on the selection line only, we will get the input of data to the output, right? Suppose here decoder output, suppose address is, slave address is this master, whatever the master side it is sending through the decoder, it will send to the slave, right? So ABCD. So ABCD slave will be selected here. Okay. We are storing the data in address ABCD. Okay. So suppose you are having 68 data. Data value is 68. Okay. So you are storing that 68 data in address ABCD. Okay. So this is slave address and decoder also getting slave address. Okay. So here selection line is ABCD. Okay. Now what is the input line? What is the common multiplexer logic?
It should have one select and 2 inputs and inputs.
So here selection line is 0, 0. Okay. So here D of selection line 0, D of selection line 1, D of selection line 2, D of selection line 3. Okay. So selection line is 0, 0. Here in previous case, in our AHP case, A, B, C, D is the address. Okay. That address is connecting to the selection line through the decoder logic. So within the ABCD, we have stored 68 data. Okay. Now this selection line value is ABCD. So D of ABCD. D of ABCD. That means whatever the data is there in this particular address, that data is getting at the output side. That means this D of ABCD have 68 data because we already stored 68 data. So this 68 data is getting outside. Okay, we are particularly selecting this address and that data is getting at the output side. Same thing here also, right? Suppose here decoder output address is ABCD. That through that ABCD, in which slave it is there, ABCD. So it will select that particular slave. Okay. Whatever the data is there in that particular location ABCD, that data will be getting here as a H read data. Okay. So that data will be assigned to the master. Okay. Parallelly, we will get H response signal and H ready signal. Clear?
Yes, clear.
So while designing, we need to give the slave addresses, or correct, right? We need to give one offset address to each slave, right? For example, if you are designing multiple slaves, or the H address will be taken.
Address will be selected by master.
Yeah, but slaves also should be there. Slaves should be registered with one offset address.
Slaves also should be there. If you are reading the data, then we need to select with respect to the slave, writing the data with respect to the master.
Okay. So my question is, when we are verifying the one master multiple slaves, so for example, our test bench is master, okay, but slave should be have some offset address, right? Then, so how can test bench will know which slave it is selecting? Like, how can it decode?
Okay. Wait. Can you tell again, master? What address master having?
Okay, if one master, 3 slaves are there.
Okay.
So at that time also, this decoder and all these things should be there, right?
Yes.
For example,
for slaves, we need to use the decoder. Even it's a one master or 3 masters. If there are 3 masters, master's arbitration is different. This decoder is only for slave.
Yeah. So how the master address will finalize to which slave it should communicate?
That's what I explained, right? Master address is 32-bit address, suppose.
I understood, but when we are designing, so we will have some offset addresses for the slaves. If the offset address is that, we need to select that slave and to communicate with that like that. I'm asking in the real time how it will be like.
Offset address in the sense any default address will be there.
Or simply how H address will be telling to communicate with that slave.
Suppose any address value you can take and tell me.
Okay.
Any address value you can take and tell me. I'm just asking you.
Okay. Let us consider cross 64. 0 cross 64.
60. Okay. Or okay. Address must be it's a 32-bit size. If we divide into the 8 bit total, suppose maybe address will be 1. It should be like offset address if you consider 0 into master, because we have only one master. This will be the H address, for example. Okay. So this H address, first of all, in address phase, it activates the address signal first of all, H address, where the operation will be happened. Okay, this entire address data, address value should be in H address. In the same time, H transaction will be there, H trans. Based on ideal, non-sequence, sequence, busy, it will be selected. Okay, same this address, 100000000. Then H writer, H size will be dependent on 8-bit or 32-bit or 16-bit, whatever you need to select parallelly, wrap or increment. Okay, in the decoder logic, this same address goes to the slave 1 and also goes to the slave 2. Slave 1, slave 2, both it will target. Okay, based on the address range matching, the decoder select the target slave. Suppose if slave 1 is having same address 0 into 1 000 3 zeros. Slave 2 having 2 000 all zeros. Slave 3 having 3 000 all zeros. Maybe it's offset address, whatever you think. So based on the targeted slave, it should select. Suppose if you see here how it is written, H select 1, H select 2, H select 3. Okay, so slaves have the select signal. H select signals will be there. Selection line X1, X2, X3. Okay, based on this H select signal, it will be activated. Decoder tells which slave should be active by selecting this H select. Okay, then the slave will receive the H address. First it will select the slave, then slave will receive the H address with respect to the, along with the H write and H size and control signals, remaining control signals. Now, if H write is 1, the slave get ready to the storing the data if H write is 1 at the given address. If H write is 0, the slave is ready to fetch the data from the given address and send it to the master. That's what will happen actually. Okay. In data phase, what will happen after one clock cycle? If AHB is in pipeline stage or whatever, the master is sending H write data to this particular address. Okay, the slave send H read data in the data read stage during read 1 clock cycle earlier. So this is what happens actually. Who drives the H address means master will drive the H address. Okay, and the H valid should be H address valid should be high during the address phase, and this address will look by the slave, selected slave through the bus decoder. Okay.
Okay, understood.
So that is what. Suppose if in the write operation, same example I'm considering, if write operation, master wants to write some data before whatever A, B, C, D in 32-bit data, right? So A, B, C, D, E, F, 0, 1. This is what write data. It should write this data into the address of 0, 1, 0000000. To this address, this write data should be right. Then what happens? First in address phase, this address will be selected and write should be high. H side should be 32-bit. And in data phase, this data will be written into the H write data based on the targeted memory, targeted register address. It will target any register address and the memory, because everywhere, whether you are writing into the slave or writing into the master, is nothing but register data. Registers will be storing the data or address. Okay, so it will target to the particular registered address or data.
Okay, thanks for the explanation.
Next, so that is what multiplexer, and here interconnecting with AHB interfaces like AHB, multiple masters and multiple slaves interconnect. And what is the difference between OK and error? Before we have seen in a APB protocol, we have slave error. Slave error in the sense it
Hello,
indicates.
Can you explain previous slide? Okay, interconnect with AHB interface. Previous slide. Hello.
This slide.
Yeah. This interconnect with AHB.
Interconnect AHB.
There is a slide which is explaining that AHB interconnect with multiple masters and slave connect.
Next slide only.
This one.
34.
This one is.
Can you
Yeah.
explain this?
Yeah, complete your question.
Like, can you explain this? Okay. Why? How it is communicated? Okay, this AHB interconnect. It's in master and slave.
Did you remember SOC?
SOC.
So here if you see, what is this interconnect? Orange color. What are these interconnects? These interconnects are nothing but AHB AXI interconnect. Okay, so here CPU subsystem. CPU subsystem is a master. Here safety subsystem is one master, and machine learning subsystem one master, memory subsystem one master or one slave, whatever the master and slave, whatever these all are interchangeable. And wired peripheral, suppose it's a master or slave, and wireless subsystem, whether it's a master or slave, security subsystem, master or slave, IO peripherals, master or slave. Master means write transfer, slave means read transfer. Okay, so sometimes memory can be the write and CPU can be read, and sometimes CPU can be write and memory can be read, interchangeable, both are. Okay, these interconnects are nothing but this interconnect, both are same. Okay, so if you see in every subsystem there are IPs. Yesterday I have shown you how APB and AHB are connecting. Okay, all these IPs will be connected to this orange color. If it is a low peripheral, suppose here Wi-Fi, GSM and remaining LTE, all these are suppose low peripherals. So in that case here this orange color will be APB, and here display, PMU, JTAG, if these are low peripheral, this orange color will be the low peripheral APP. And here memory side, obviously we use high speed only, so it may be AHB. Here this orange color will be AHB. Like that, every subsystem we have these interconnects. Through these interconnects only we are communicating with the remaining processors or graphic processor or DSP processor, whatever. This big interconnect is nothing but main bus and interchanging the data between the processors and the memories. Okay, this big interconnect will be AXI mostly. And if you observe here, non-coherent interconnect, coherent interconnect. In the first session, I told you what is the difference between non-coherent and coherent. Non-coherent is nothing but wherever we don't have the core will be available in only processors, right? Processor subsystems only. Remaining all blocks are normal IPs, normal digital blocks. We don't have the cores. Only in the central processing unit, only in the CPU and GPUs we have the cores. Okay, So core related test cases will be different and core related hardware design will be different. Remaining digital circuits will be different. Hardware or even test cases, everything is different. Okay. So core related will comes under cache coherent interconnect and core. If you see here, coherent interconnect, and non-core subsystems will connect with the non-coherent interconnect. Okay, that is the difference. These interconnects are nothing but here, but here we connected AHB to AHB, but in real time we connect AHB to AHB, AHB to APB, APB to AXI, AXI to APB, like that.
Yeah, understood.
Next, transfer responses. In APB protocol, we have slave error, right? In the same way, in AHB protocol, we have OK response and error response. OK is nothing but the transfer has either completely successful or additional cycles are required for the subordinate to complete the request. So the H ready out signal indicates whether the transfer is pending or complete. Okay, that is OK response. If transfer is completed, we get the output as high. If it is not completed, 0, but we don't get the error. There is no error. But whether transfer is pending or completed, just it will tell successful or unsuccessful. Okay. And coming to the error, error means if any output is mismatched with the input data, it will show the error. Okay. So the error condition must be signaled to the manager so that it is aware the transfer has been unsuccessful. A 2-cycle response is required for an error condition with H ready out. And next H ready out, H response. Okay, same. H ready out, H response. 0, 0 means transfer pending. H response 0, H ready out is 1. 0, 1 means successful transfer completed. And 1, 0 means error response first cycle. 1, 1 means error response second cycle. Okay, both address phase, data phase. It will tell if it is error in address phase, then 1, 0. If error is in data phase, 1, 1. Okay. This is what error response. Whenever error is getting, it should be H response should be high. If H response is 0 means what? Okay. Okay. Same H ready. Not H ready. H ready out. You can mention, you can have the waveform here for H ready out also. If H ready out is 0, error in first cycle. If H ready out is 1, error in second cycle, it will indicate. Okay. So that is what AHB protocol. We have 2 more topics in AHB.
Ma'am, when error will be generated?
When both data and address are mismatched, both are not correct.
If one is mismatched, either
Not
data or
see, you are not comparing with the address and data. Do we compare with address and data? Both how it will be matching? Write data, read data, write address, read address. You need to check. Will you check with address and data?
no.
No.
Then
Ma'am, we are comparing.
tell.
Ma'am, we are comparing with whom?
With write data, read data. Read data, write, read. Whatever it is, address and data. Both we need to compare, right side, read side. Didn't understood. Huh?
Yes, ma'am.
Specification, everyone complete the specification. Already we discussed most of the topics. Whatever we discussed, same will be there here also. Two concepts are there in AHP, split and retry response. In this specification, not there. Is it light? Okay, fine. I will explain separately. So, split and retry in AHP protocol. Split and retry means, suppose these are for ways to handle the slave. Okay, slave need to handle the situations whenever we cannot immediately complete the transfer which is requested by a master, right? Master has requested a transfer, one transfer, suppose one transfer is master side. Okay, so slave should complete that transfer. Okay, so slave cannot immediately complete this transfer which is initiating by the master. Okay, so slave have some delay. Okay, both it should allow a slave to delay the completion. If it is not completing means slave will require some delay, right, without blocking the bus. Okay, so that other masters can use the bus in time. In that time, another masters can use. Only for slave, it is giving some delay to complete that functionality or to complete that transfer. Okay, so that other masters using the same bus. Okay, however, here we use the two concepts, split and retry. Both are different purposes and both are different use. Okay, so why do we need the split and retry means, sometimes suppose here if a slave need the extra time before it can finish a write or read request from the master, slave needs some time. Okay, then suppose in real time, if you see, there is a SOC. In SOC, there is a suppose there is a memory. Okay, and also suppose it's a flash memory and some external RAM is connected. Not only SOC, suppose if any two blocks you are connecting, suppose there is a flash memory and there is a RAM. Okay, so the slave is fetching the data from a memory or external RAM. Okay, so the slave is waiting for some internal operation to complete here. Slave is busy handling, and the slave is having some another data, or it is a busy in another request. Okay, so in such cases, suppose instead of making the master to wait, okay, the slave can send a split or retry response to the master. Split or retry response. That means what? Split means split is used whenever slave cannot respond immediately. Whenever slave cannot respond immediately and masters want to leave the bus just for now. Slave is in busy state. It is doing some other task before task. Slave is not able to respond to the present master transfer. Okay. So in that case, slave is sending split response. Okay. It is telling like it cannot respond immediately. So master should leave the bus for now, as of now. Okay. So the slave will remember the master after some time, whatever it made the request. So master already made the request, right, to complete the transfer. So slave will remember to the master for the request using something like split ID. There will be some split ID. It sends the split signal. It will put that transfer as a hold. It will remember in this memory. Okay, master is initiated some transfer. I need to take it after present operation is completed. I should get that transfer and need to do the task. So the slave will remember it in the memory based on the split ID. Okay, it will remember the master, so that other masters they can use the bus. Meanwhile, the slave will get ready to get this transfer. Okay, so once the slave is ready here, it will inform the arbiter, the master's arbiter, that the original master can re-arbitrate for the bus and retry its transaction. That's what retry means. Okay. Split means slave is telling to hold the transaction for the master. So master M1 is holding its transaction. Okay. Meanwhile, M1 is giving the arbitration, giving the bus to M2 or M3. Okay. Now, whenever slave is okay to get that particular address data, the slave is remembering to the master 1, okay, to initiate the transfer. Okay, that is what retry. Okay, so the original master can re-arbitrate for the bus immediately. Immediately, whatever before data is holding. Okay, whenever it got the access, whenever it got the whatever message from the slave, okay, immediately it will ask for the re-arbitration and it retry its transaction. That's what split and retry. Okay, so master must not retry immediately, but it should wait. It should wait until the slave tells the arbiter it's ready. So that is what retry and split response. Okay, understood? Retry is nothing but retry will be used whenever the slave is temporarily cannot respond. Slave is not responding for temporarily. Whenever slave is not responding, the retry can be used. So based on it expects to be to ready very soon, right? So whenever it is ready, the master will retry. That is what retry. Split means slave is telling to wait for the master. So these are what AHB concepts. Everyone must go through the specification once. At
Ma'am,
least.
please explain the last topic which you explained in the print.
What did you understood from that?
Please explain it. I can't able to
What
grasp
did
it.
you understand? Explain me. I will explain. Then what did you understood here? There are multiple master. Master 1, master 2, master 3. And there is a slave. Okay. So slave is doing some operation. It is in busy state. Okay. Master is sending some transaction to the slave. Okay. So slave is some busy state or else it is having some delay to complete the present transaction. So not able to respond to the master data. Okay, whatever the master is initiating, slave is not able to respond to that particular address. Suppose master is initiating to the address ABCD. So slave is receiving the address ABCD. To receive this particular address in first slave, it is busy. Okay. Now, whenever it is busy, it is telling to the master to split. Split in the sense to wait. Slave is telling for the master to wait. Okay. So master is waiting here. Okay. So without waiting or without wasting the time, this master is sending to the arbitration again. It re-arbitrated or it released its arbitration. So now through the arbitration, any master 1 or master 3 are selected. Okay. Maybe if master 3 won the bus and got selected a slave and transferring the data from M3 to slave. Okay. Now,
Yes, ma'am.
now this slave, whatever the busy state is there, it completed its busy state. Okay. It completed its present task or transfer, whatever. So now slave is free. Slave is ready to accept the data from the master. Whatever it is giving the address ABCD, the slave is ready to accept that address and accept to the write operation or read operation. Okay. Now slave is telling to the master through the split ID, it will send the response to the through the split ID, so that master will understand slave is now ready to accept the data. So M1 can transfer the data. Master will think like that. Okay. So master will understand like that. So the master will re-arbitrate. Re-arbitrate means whatever it lose before the bus, it will ask for the bus. Okay. It will take time because present transfer should complete, right? Whatever M3 is transferring to the slave, it should complete that present transfer. Okay. So obviously M1 should wait for some time. Once M3 is completed, immediately the bus will be won by the master 1. That means the arbitration will be selected to the master 1. So master 1 is retrying for the bus. That is what retry. Split to retry. Split means it is slave is telling to hold, to stop, to wait, not stop, to wait. Retry means once slave is ready, master is retrying for the arbitration. That's what retry. So once the master 1 got the bus, it is ready to transfer the address and slave is accepting the address and they do the write and read operation. That's what retry and split in AHP. Mostly we use these features in industries only, not at project level.
Okay, ma'am. When ma'am slave is free,
Mm.
he gives signal to the master. Split ID.
Yes, split ID.
Okay.
So it will retry for the arbitration again.
Yes.
It will wait until M3 is complete so that M1 will get the bus so that it will initiate the transfer.
M1 and M3 is trying to send data to the same slab or different slab. The black slab is and red slab is
Depends
different
on
or same.
address. It depends on address. I already told there will be multiple slaves based on which address which slave is accepting, that slave will be selected using decoder. Okay.
Okay.
So next
Sorry to
code
interrupt, ma'am. Actually,
coding.
only AHB2 will support this split and retry. Okay. In the later versions, they have removed this concept.
AHP2 after we got AXI, right? Basic version.
Yeah, but in the AHB3 and AHB5, AHB Lite, we don't support this retry and split.
HP Lite we don't have any even
Yeah.
burst.
Arbitration. Yes, I know. I'm sorry. But in AHB3, AHB5, I downloaded yesterday, but they removed those concepts actually. If you want to,
Which one it is?
that is 5 only.
Okay, that's why I'm not able to find here split.
Yes. Yeah. So if you want to use these concepts, we have to do HB2. Otherwise, we need to do AXI because we are having better
Okay,
features. Yeah.
fine. So, okay, next AHB design. It takes 1 more hour. We can discuss in the weekday. Okay, in weekday we will discuss design and also we'll discuss an UVM test bench. In the next week we will discuss AHB2, APB, bridge. Okay, bridge is in RTL design. We will complete that. Okay. Any other doubts for today? Any doubts? Aditi,
Yeah, the
Ashwin,
bench
Gopika?
architecture. Yeah, ma'am. I have only one question related to the verification. So the test bench example you are going to explain us is like an bridge, right? AHB master to slave, APB slave, or you will explain us first AHB as it is, then.
First, I will explain individually. AHB, APB already explained, right?
Yeah. So I'm just asking, you want to conclude the topic by
Bridge.
explaining the bridge and then.
What conclusion?
No, I'm asking like first you will explain us the verification only AHB itself, and the next project will be how the bridge how it will work.
Bridge functionality is different. First, I will explain you AHB. This is designed. In AHB, we design total like this non-sequence, sequence, busy, transfer, okay, response, error response, and there are all features like in burst transfers we do wrap, increment, single transfer, increment burst, undefined length, and 4-bit wrap burst, and 4-bit incrementing burst, 8-bit wrap, 8-bit increment, 16-bit wrap, 16-bit increment. So all are there. So first we are going to complete this design and then we are going to complete the verification. Okay. So then bridge.
Understood.
Okay. Okay, then that's it. Thank you all. Bye.
Thank you.
Yeah, thank you.